And there's a session. So let's go to question 10. June 2021. Yeah, June 2021. Okay, so without reading all the statement, I'll just like explain the one of the important information is that this one right here is a tangent, and this one is a diameter for the bigger side. This line QR is parallel as MS. Yeah, so I think that's the most important part in this one, and these are the radius. You just can like see them because this is center, which is S. Okay, so let's go to 10.1. So when you go to 10.1, they say they are proof giving reason that SQ, this thing right here, is a diameter for the small circle. Okay, so how can you prove that? If we can get that this angle is 90 degrees, it's gonna prove that this thing should be, this should be a diameter, or it passes through the center. So now if you can check in the bigger side, this thing is a radius and this is a tangent. So what's the angle here? It should be 90. So if this thing is 90, to prove that this one should be the diameter. So you can write like this one. Okay, so it's going like 10.1.1, 10.1.1. We can simply say that SQR, this one is same as 90 degrees. This and here, SQR. What's the reason for that? It's tan perpendicular radius. Okay, so that's the reason, and therefore we can simply conclude that SQ is a diameter. SQ is a diameter. That's all. Okay. Now let's go to the next one, which is question 10.1.2. Okay, so when you go to 10.1.2, they say we need to prove that RT is same as RQ squared over your RP. Okay, how can I prove that? Where's your RT? Your RT is in this shape. It's over here. This is your R. Is your TR. Yes, is your RT. And where is your RQ? Your RQ is over here. Here's your RQ over here. Okay, RQ. When is your RP? Your RP is RP. This is your RP. So we're dealing with these two shapes. Okay. So when you're dealing with these two shapes, now we are trying to find that RT. So the best way to do this is to work with similarities and work with the proportion. Okay. But I need to prove that if these two triangles, are they the same or not? I mean, are they similar or not? So for me to prove that, I need to use the angles. Okay, right now I have 90 here. I don't see 90 in this shape, which means I need to find a way to have 90. So one thing I noticed that earlier on, I noticed that this angle right here, let me show you, this angle right here is 90 degrees. Then the question is, if this angle is 90 degrees in the small circle, this angle should also be 90 degrees, which means I can write this down as that M1, is that TS SQP, this angle is equals to my M2. What's the reason for this one? This one is actually a tan chord theorem. Tan chord theorem. Okay. So now this is 90, and after that you're gonna notice that what is this? You're also gonna notice that this angle right here. Okay, this angle right here, let me talk about Q1 and Q2, should also be 90 degrees co-integers. Okay, you can say that Q1 plus my Q2 should give me 90 degrees. What's the reason for that? The co-integers of the parallel, co-integral of part of the parallel lines. Okay, parallel lines, which is MS and let me write the M here, MS and QR and QR. So which means this angle right here, this angle is 90. Now on this shape I have 90 degrees. Let me erase the other one. On this shape I have 90 degrees. I have 90 degrees here, and I have 90 degrees, and this angle is the same as that one. I can now prove the similarities of these two triangles. Now you're going to write this thing down. How are you going to do it? You're going to say in triangle, okay, in triangle TQR TQR and triangle QRP. Now what you're going to notice is that M1 is the same as P. M1 is the same as angle P. Okay, we can say this one is proven, or we just like given. You can write like that. It's proven because we proved that this one is same as 90 degrees and also given on this side. And after that, we're gonna notice that Q3 is the same as your angle T. Okay, how did you see that? If you see over here, okay, sorry, the angle over here is the same as this one. Let's check in the bigger side. You see the triangle, okay, inside this bigger circle. So this end right here is the same as this one. What's the reason for that? This one is tan-cot theorem. Tan-cot theorem. Okay. Now the next one we need to go, the last one we don't need to do is R1 and R2 because we are working with these two shapes. So R1, okay, you can say R1 is the same as your R3. You can say sum of angles in a triangle. Yes. Now we can then conclude that triangle TQR is similar to triangle. So this angle T is the same as angle Q. It's similar to triangle Q, and this angle Q is over here. On this one is the same as P, and P, okay, and therefore R is the same as R, and therefore we're gonna put R. What's the reason for that? It's angle, and then the angles. Okay, now after this one, what you'll work on now, you have proved that this is similar, and therefore you're going to work the ratios. This one over this one is the same as this one over this one, same as this one over this one, which means TQ over QP is the same as QR over PR. Okay, yes, PR, QP over QR is same as again last one, TR over your QR. Okay, this is looks like, and therefore here you're going to check is QR is QR, here's QR squared, which means PR, which means only going to need this. Okay, and I'm just going to cross multiply, and then when you cross multiply, you're going to find that the TR times your your PR is equals to this sum. This is going to give you RQ squared, and you just divide by RP, divide by RP, sorry, you divide by RP, you divide by RP, okay, divide by PR, I mean to say, by PR, this will cancel this over PR, which means your TR is equals to RQ squared over RP. Okay, I think you have proved that. So this is how you actually gonna prove it. Okay, that was 10.1.1. Now let's go to 10.1.2. I'm gonna start here. Okay. Now 10.1.2, 26 marks question. 10.1.2, they say there, 10.1.3, I mean to say. 10.1.3 is also a 10.2, yeah, it's 10.2. 10.2 is also a 6 marks question. How are we going to answer this one? Okay, let's see what they're saying. Now, if MS is 14, where is MS? MS, they're telling us over here, this thing is actually a 14. Let's write that. This is 14. Okay, and PQ is the square root of 40. Okay, 640, I mean to say. And they say their units calculate given reason the length of the radius. They want the length of radius. Okay, they want the length of each radius. Okay, how are you going to get that? So working on that, first of all, if you look here, we have this shape and we have these two shapes again, and you have this and you have this. So what do we need? We know that RT is the same as your RT is the same as what? As RP and your RQ, and they are in these shapes. So which means my job, if I can work RT and divide it by 2, I'm going to get the radius. So which means I need to work with this one. The question, how can I get this side and use Pythagoras theorem and get my RP? If I get my RP, I'll be able to get this side over here. So now the first thing I need to do, I need to prove that I need to get my RQ. It's my RQ first. So how can I get RQ? So now we know that TS, this is the same as this, which means my TS is the same as my, I can say my RS. These are the radii, right? Okay, so now if this is the same as this, and this one is parallel to this, okay, it means TM is the same as MQ. Or we can say that MS is parallel to QR. What's the reason for this? This one is just given. Okay, so now which means therefore we can conclude that in my TM is the same as my MQ. What's the reason for this one? This is the converse, okay? Converse of the midpoint theorem. Okay, so now I know this one is the same as this one. What this means, we can say that my QR, okay, my QR is the same as my 2 times 14. Or we can just multiply this by 2. What's the reason for that? This is a midpoint theorem. Midpoint theorem. Okay, so once we have that, which means my QR is equals to 28, which means over here is giving me 28. Now I have this one. So what is the next thing? 28 unit. Now I have this one. I can use Pythagoras theorem. So if I use the Pythagoras theorem, it's going to be it's going to be QR squared equal to QP squared plus my RP squared. Just the reason it's Pythagoras theorem. Okay, so now I'm trying to work out my RP. I'm trying to work my RP. So we're gonna my QR is 28. This QR is 28 squared. 28 squared equals to my QP. My QP is going to be the square root of 640. All right, it's given that, but the squared equal to and therefore let me read this part. And over here plus, okay, plus your RP. Your RP is going to be RP squared. So you're going to work out. Okay, I'm going to explain what you're going to do to make it short. Take this to the other side and put the square root. You're going to find that at the end, your RP is equal to the square root of 28 squared plus the square root of 640 and therefore squared. And therefore you find that your RP is equals to 12 units. So once you have your RP, okay, now we know this value right here. Once you have your RP, and you do know your RQ. So what you're going to do, you're going to say that you're going to try to work out the value of RT. We know that RT is equals to RQ squared over your RP, then equals to your RQ. Your RQ is 28, which means going to be 28 squared over your RP. Your RP is what? Your RP over here. Your RP is calculated as 12 units. We calculated over here. You're going to find that your RT is equals to, it's going to be 65.33. It's going to be 65.33. And therefore, we divide this by 2, and then you get the radius. Because now you know that your RT is 65.33 units, which means now you're going to say 65.33, then you divide this by 2, will give you the value of 32.67. This is your radius. Okay, this is your radius value. Okay, so that's how you're going to work out that part, which means I can conclude by saying therefore now the radius is equals to 32.67 units. That's how you're going to work this out. That's how you're going to handle 10.2.